This lesson describes the creation and use of clusters to group data of mixed types. A cluster allows you to combine related data elements of different types into a single data type. Clusters can be used for elements with identical data types when you need to name individual items. The figure shows a cluster that combines information that all relates to weather data. A cluster is functionally similar to a record or struct in text-based programming languages. Most clusters on the block diagram have a pink wire and data type terminal. It's possible to access the individual data elements that are stored within a cluster. Clusters and arrays are similar in that you can use both to collect related data into a single data type. There are two key differences between these data types. Clusters allow you to combine data of different types, whereas an array can only contain one data type. Clusters contain the number of elements that you add when you create the cluster. The number of elements in an array can be programmatically modified at any time. Now that we understand what a cluster is, let's discuss why you should use them. Clusters help to improve data organization both on your front panel and on your block diagram. On the front panel, the cluster ensures that you never accidentally separate related controls or indicators. The cluster border visually indicates that these items are related to each other. On the block diagram, instead of having a separate terminal for each data element, the cluster is shown as a single terminal. This enables you to keep the data together when passing it to other VIs on your block diagram. Clusters that contain only numeric values have a brown wire and data type terminal. You can wire numeric clusters to numeric functions to perform the same operation simultaneously on all elements of the cluster. Bundling several data elements into clusters eliminates wire clutter on the block diagram and reduces inputs and outputs for your sub-VIs. Let's take a look at creating clusters on the front panel and block diagram. We'll begin by creating a cluster control. First, we'll create an empty cluster. Now, we'll add several data elements. Now let's create a cluster constant on our block diagram. To do this, we can either create it from the cluster control we already made, or we can create it manually. And just like on the front panel, we can populate this by selecting our data elements. The cluster order is analogous to the index of elements in an array. If you wire two clusters together, corresponding elements, determined by the cluster order, must have compatible data types. The default cluster order corresponds to the order in which you added each element to the cluster. If you delete an element, the order adjusts automatically. You can change the cluster order by right-clicking and selecting the Reorder Controls in Cluster option. When you create a cluster, the data elements will probably not be evenly spaced or aligned in the cluster. Select Auto Sizing from the menu to automatically resize and rearrange the cluster. Use the functions unbundle cluster and bundle cluster to read and write cluster data. Use the unbundle by name function if all elements in the cluster have names. Use the unbundle function if some or all cluster elements are unnamed. Now let's look at how to read and write cluster data. This example reads the current and maximum temperature values from the weather data in a cluster and compares them. The VI then writes warning data to the weather data out cluster. Make sure you've wired the input cluster terminal of the bundle and unbundle by name functions. If you do not wire this input, the function creates a cluster. Now let's look at how to read and write cluster data. In this example, we took several controls and indicators and combined them into the weather data cluster. We placed two instances of that cluster on our front panel, the weather data in control and the weather data out indicator. Now let's take a look at our block diagram. As you can see, it's unfinished. First, I'm going to place an unbundle function here. When we wire the unbundle function, we're able to select which cluster values we want to read. I'm going to stretch this, and we're going to read the current temperature, the maximum temperature, and the minimum temperature. And now I'm going to wire this to our block diagram. Let's take a look at how we can write data back into this cluster. I'm going to place a bundle function. From here, I'm going to wire the cluster across, and I'm going to specify which values I want to write. I want to write warning, and I want to write warning text. And now I can wire warning and warning text. And I can wire the weather data out cluster. You can also programmatically create a cluster by using the bundle function. An error cluster contains the following elements: status, code, and source. You may encounter a situation where you want to include multiple plots on your chart. To do this, use a bundle function to combine a single Y value for each plot into a cluster, which you can then plot to a chart. Notice that this technique only works for charts. If you want to combine plots for a graph, you'll need to use the build array function. While charts and graphs will probably satisfy most of your needs, you may encounter situations where you need a different option. To create an XY plot, use the bundle function to combine the X and Y arrays into a cluster, which you can then plot to an XY graph. Use the Context Help window to determine how to wire multi-plot data to graphs and charts. Now let's take a look at an approach for displaying arrays of cluster data. Here we see a simple one-dimensional array of weather data clusters. Let's take a look at the block diagram to see how this is generated. We have several instances of the Acquire Weather Data VI, and we're taking the cluster outputs and building an array out of them. Now let's go back to our front panel and run the VI. Here's a summary of what you've learned in this lesson.